everyone, welcome back to another GCSE Maths lesson with Rao. Today we are exploring angles in parallel lines, so things are getting a little bit more challenging here. This is a key topic in geometry, and understanding it will help you solve many angle problems with ease. So let's dive right in. Let's look at some key vocabulary to do with angles and parallel lines. Now, parallel lines are two lines, like this, straight lines, that will never meet. The reason that they will never meet is because they're always going to be the same distance apart. So no matter how much you extend these two lines, they're never going to meet. And they're commonly kind of identified by having arrows like this. So if you have one set of parallel lines, you get something like this. If you have two sets of parallel lines, they'll be straight lines. So excuse my horrible wobbly lines, but to tell you there's a second pair of parallel lines, then you put two of those arrowheads and so on. So arrows tell you that they're parallel lines. A transversal is a line that crosses parallel lines, and it could be in any kind of angle or direction. So a line like this, a line like this, a line like this. Not going to be a straight line, but it's always going to be at an angle, but direction-wise, it does not matter what direction is crossing the two parallel lines at. A transversal is a line that crosses the two parallel lines. Corresponding angles. So if you have two parallel lines, and there's a transversal, so a line that cuts through these parallel lines, there are a pair of angles, well, there could be more than one pair, but they're a pair of angles referred to as corresponding angles. So corresponding angles are angles in terms of the mathematical term or mathematical definition of it. They are angles in the same relative position at each intersection. So we have an intersection here and an intersection here. So same relative position would be this is the same relative position as this. So these two angles are going to be the same as each other. And this is the same relative position as this. So these two angles are going to be the same as each other as well. But there's one other way that is used to kind of hint where these could be, where you can spot an F. Can you see that? I hope that you can see that. The internal angles of the F, so this angle and these two angles are corresponding angles and are equal to each other. You can also have an upside down F. So then this angle is the same as this angle. And these are referred to as corresponding angles. So where you can spot the F, you have the corresponding angles where they are in the relative position at each intersection. Next one are alternate angles. Now, alternate angles, again, the mathematical definition is they're the angles on opposite sides of the transversal, but inside the parallel lines. So opposite sides of the transversal, these two would be the same as each other. These two would also be the same as each other. Again, another way to spot these, if you can see a Z, this is a Z. If you can spot a Z, the internal angles of that Z would be the same as each other. This would be the same as this. Alternate angles. You can have a rotated Z. So if you also have this, then the internal angles of this opposite Z, rotated Z, would be the same as each other also. And these are known as alternate angles. Now, the F and the Z is there to help you kind of identify where they are. But the key piece of information you always look for are their parallel lines. And then from there, can I spot the shape? And then we have what we call co-interior angles. And that's when angles on the same side of the transversal add up to 180. So similar to what we looked at before, angles of a straight line will add up to 180. So these angles will add up to 180. Now, so angle rules in parallel lines. So the most important ones to know are the ones that we went through. So corresponding angles will always be the same as each other, where you can spot the F shape. Alternate angles, where you can spot the Z shape, will be also the same as each other. Co-interior angles, where the two angles along a straight line will add up to 180. And we use these rules to solve angle problems in parallel line diagrams. Now, there could be more shapes involved with the parallel lines, and we're going to look at some examples now. So let's dive straight into it. Okay, so let's look at example 1. In the diagram, AB is parallel to CD, right? And one thing I want you to remember with these questions, with any mathematical question as a whole, if there's a piece of information given to you, it's there for a reason. So they're telling you straight away that we have parallel lines. That means angles of parallel lines are going to have a play here. We're going to use them somehow. The question says, work out the size of angle marked X and Y, give reasons for your answer. And when it says give reasons for your answer, you're going to state and write this down every step. And so we're looking for X and Y. The way that we can do it, can we spot an F and a Z? I can spot them both. I can see a Z shape here straight away. That tells me that this angle and this angle are the same as each other, right? So this angle is 135 degrees. So X and these two angles, angle X and this angle here, are will add up to 180. They're co-interior angles. So if I want to find out what x is equal to, I would do 180 minus 135. I can't subtract 5 from 0. I'm going to borrow 1 from here. That becomes 7. That becomes 10. 10 minus 5 is equal to 5. 7 minus 3 is equal to 4. 1 minus 1 is equal to 0. So that angle there is equal to 45 degrees. So then you would say angle x is equal to 45 degrees. And when it says give reasons for your answer, that's exactly what you do. You kind of just write a line stating what you did for every step. These two angles are alternate, these two are co-interior, so we subtract and find it. And the subtract part you just demonstrate as you subtract it. Right, next question. Angle AB is parallel to CD. Work out the size of angle Y. Give reasons for your answer. Okay, angle Y. So the first thing I spot straight away is an isosceles triangle. So isosceles triangle means this angle and this angle, they're going to be the same as each other. So that's literally how you would write it down. So QRT is equal to QT, so angle, QRT is equal to angle QTR, right? And you would literally stick this down because it's an isosceles triangle, the angles will be the same as each other. So if you can spot this Z, this angle is going to be the same as that angle there. So that is 154. Some of the interior angles of a triangle are 180. So we're going to do 180 minus 154 to find out what these two will add up to. So let's do that. We can't take away 4 from 0. We borrow 1 from this. That becomes 7. 10 minus 4 is equal to 6. 7 minus 5 is equal to 2. 0 minus 0 is equal to 1 minus 1 is equal to 0. So these two angles will add up to 26. So because we know that it's an isosceles triangle and they're exactly the same, we're going to split that into 2. So that gives us 13 degrees. That is equal to 13. That is equal to 13. So 26 divided by 2 gives us 13, which is what these two angles are. Right? So if this is 13, these two are co-interior angles. So we're going to do 180 minus 13. We can't take away 3 from 0. We borrow 1 from here. That becomes 7. Sorry, that's a weird 7. That becomes 10. 10 minus 3 is 7. 7 minus 1 is 6. 1 minus 0 is 1. So y is equal to 167 degrees. And again, you would state every step that you took. So first thing, isosceles triangle means these two are the same as each other. One sentence explaining that. TQR and CRQ are alternate angles and the same as each other. So that means this is 154 degrees. That's the second point you're going to make. Then you're going to write down some of the interior angles of a triangle are 180. So 180 minus 154 is equal to 26. So these two angles equal to 26. We divide that by 2 and we get each of these angles. Once we've got that, this angle and angle Y are co-interior angles, so we subtract 13 from 180 and we got the size of angle Y, which is 167. So one sentence for every step that you took and you get the full marks in that sense. Right, question 3. In the diagram, AB is parallel to CD. Work out the size of angle X. You must show your working. Okay, we're looking for angle X. Okay, sometimes the parallel lines might not look typically like the two parallel lines you have like this, the way they represent it in a diagram. So AB is a parallel line, CD is also a parallel line, but in order to spot things, sometimes it helps if you extend these lines so you can see, you can spot the patterns. So what I'm trying to demonstrate there, hopefully, is that we can see an upside down F here. That means these two angles are going to be the same as each other, corresponding angles. So if these two angles are going to be the same as each other, then can I find out what this angle is equal to? Yes, I can. I can work backwards. So to find out what this angle is equal to, I need to find out what this angle is. And then I know the sum of them is 180. So I can subtract this and this angle from 180 to find out this third angle. This angle and this are co-interior angles. So I can do 180 minus 116 and see what that angle is equal to. So I can't take away 6 from 0. I'm going to borrow 1 from 8. That becomes 7. That becomes 10. 10 minus 6 is equal to 4. 7 minus 1 is equal to 6. And 1 minus 1 is equal to 0. So that angle there is 64 degrees. Now I know the sum of the interior angles of a triangle is equal to 180. So I'm going to add these two and then subtract from 180 to find out what this third angle is equal to. So 64 plus 51, sorry, not 4. 4 plus 1 is equal to 5, 6 plus 5 is equal to 11. So 115. Then if I do 180 minus 115, I get this third angle. Again, I can't take away 5 from 0, I borrow 1 from 7, that becomes 10. 10 minus 5 is equal to 5, 7 minus 1 is equal to 6, 1 minus 1 is equal to 0. So that third angle is equal to 65 degrees. These are corresponding angles, so that is also going to be equal to 65 degrees. Right? Hope that makes sense. Let's keep going. Right, let's look at some common mistakes to avoid. The most obvious thing that I'm going to say here is confusing alternate angles with corresponding angles. Now, the Z and the F are there to help you. Can I spot a Z both rotated or not? Can I spot an F upside down or in the normal manner? That's going to help us find out which is which. So be very careful to make sure you select the right ones and not confuse them with each other. And also, it's important not to confuse the names, because if you spot the right angles, which are the same as each other, but they're corresponding angles, and then you write down their alternate angles, you're going to lose a mark for saying the same name, even though your calculation is not going to be impacted because you know which two angles are the same as each other. So be careful with that. The other one would be forgetting that co-interior angles add up to 180 instead of being equal. So because corresponding angles and alternate angles are, we say, equal as each other, but in co-interior angles are not equal as each other, but they add up to 180. So just remembering that rule, be careful with that. And then not recognizing parallel line markings in the diagram. So it's very common where you get a question, and in that question, like the previous one, it's not very obvious that they're parallel lines, and you kind of are not able to spot the transversal of the parallel lines because they're within a triangle, right? Or within a rectangle. You could get a question that's something like this, terribly drawn, but these two, and it's labeled like this. So, and then it would say find, and then you might have a line like this, and then it would say something like find this angle, or vice versa. But what students very commonly miss is that these two lines are actually parallel to each other, and this line is a transversal to those parallel lines, which is why I always say extend your lines like this. If it helps you spot the pattern easier, then do it. If it helps to scribble that on the side so you don't need to draw these lines and you can spot which of these angles are corresponding, which are alternate, and vice versa, then do so, right? Whatever helps, do it in that sense. But just remember the Z shape, the F shape, and then if you've got two parallel lines and the line is cutting through, that's a transversal there. So just remember those and it'll help you in recognizing them. Right, I have a practice question up here on the board. I'd like you to pause the video and have a go at doing this by yourself. See if you can spot the patterns, spot the angles that are needed, and work backwards to find what you need. And then once you've done that, carry on with the video. I'm going to go through the answer in just a second. Good luck. Right, okay, let's run through this and double check as I'm going through it. The lines DEF and GHI are parallel. You can see the arrows there indicated as well. Work out the sides of angle IHB. Give a reason for each stage of your working. Okay, it's also labeled as X, so that is the angle that we are looking for. Right, first thing that I see is that triangle there, right? If I'm looking for X, then I can use the triangle. I can find out what this angle is equal to because I know these are angles of a straight line, so they're going to add up to 180. So these three, I can find out this one in the middle. Once I know this one is already given to us, I can find out this third angle. And once I have this angle, I'm going to be able to find X. But how do I find X? I can spot this Z shape right there. So this whole angle, I'm going to label it like this, is going to equal 58 degrees because it's an alternate angle to this. So if I find out what this one is equal to, I can subtract it from 58 to find out what X is equal to, right? So let's do it. Let's find the third angle of the triangle first. So if I add 58 to 30, which we can do without really even using the column method, but 8 plus 0 is 8, 5 plus 3 is 8. So that is 8. These two add up to 88. So if I subtract 88 from 180, I'll get this third angle there. So I can't take away 8 from 0. I borrow 1 from 7. That becomes 10. 10 minus 8 is equal to 2. I can't take away 8 from 7. I'm going to borrow 1 from this. This becomes 0. This becomes 17. 17 minus 8 gives me 9, which gives me a total of 92. So that angle there is equal to 92 degrees. Right, then to find this third angle here, I'm going to add 92 to 37 and then subtract from 180 because the sum of the interior angles of a triangle is equal to 180. So 92 plus 37, 7 plus 2 gives me 9, 9 plus 3 gives me 12, so 129. So then if I do 180 minus 129, I can't take away 9 from 0, I'm going to borrow 1 from here, that becomes 7, that becomes 10, 10 minus 9 is equal to 1, 7 minus 2 is equal to 5, 1 minus 1 is equal to 0. So this angle here, just for this part, is equal to 51 degrees. So the angle of 51 degrees and x add up to 58, so that means angle x, or IHB, is equal to 7 degrees. Right? Did you get that right? Leave a comment with your answer and any questions you have. Right, so well done. That is it for today's lesson on angles in parallel lines. If you found this to be helpful, don't forget to like, subscribe, and hit the notification bell for some more GCSE lessons that we're going to release every week. And